So I'm Gauthier Picard. I'm a senior research scientist at ONERA.
My name is Cédric Pralet, and we are in a department called the Information Processing and Systems.
I'm Marie Devant, and I work at Capgemini as a product owner for the Coverage Service application.
In the Coverage Service is how to split large areas into subregions and assign these subregions to different missions.
So the Coverage Service application is an application which aims at providing for a huge area the most efficient dispatch between mission chains to take the picture more efficiently.
For instance, if you want to monitor a phenomena on Earth that requires to be frequently observed, we can say, for instance, maybe biodiversity, but also just a phenomena like fires or growing of urbanization, and you want to frequently pass, and maybe at some point, if there is one point of a phenomena that is diverging, you want to follow this like a fire which is spreading and at some point is going elsewhere. You want to keep track of this to follow the phenomena as fast as this phenomena is evolving. Okay, so it requires reactivity and to be able to acquire large-scale area very fast.
Imagine you have a small area to cover. To cover this small area, the satellites will perform small images, and if you have a very small area, maybe you need something like 10 images to cover the area. And suppose you have two systems, system A and B. One question is, how do I dispatch my 10 images over the two systems? And the number of possible dispatch decision is 2 to the power of 10, that is about 1000. This is already quite big, but imagine now that we have a larger area requiring something like 60 images. In this case, if you still have two systems, you have 2 to the power 60 possible dispatch decisions, which is billions possible decisions, and our goal is to find one solution that has a good quality among these possible decisions.
The Coverage Service originally was a prototype, but we decided to go a bit further and to build the Coverage Service application with the same standard that we use for other operational systems. And so we're trying to develop an application which is as close as possible to an operational system.
We are doing very fundamental research about the algorithmics behind these decision problems, and we assess the performances of these algorithms using real data. So in the Domino project, we have access to the real configurations of the constellations. We can have access to realistic order books so that we can fine-tune our algorithms using this real data.
It's like a game, and to play this game, we develop algorithms to search as efficiently as possible.